Okay, so this is the next gear problem solution. So I'm just going to go ahead and go through that. I've kind of sketched out the gear system that's in the problem you have. You have the motors behind Z, all right, for gear W, N equals 15, N equals 30 for that gear. This is Y with N equals 60, and that's Z with N equals 20. All right, the motor turns clockwise. What direction does X turn? So we have a motor turning here clockwise, right? Which means that this one has to turn counterclockwise. And this one has to turn, because they're on the same shaft, right? So they both turn counterclockwise, which means that X is going to turn clockwise. So X turns clockwise. All right, the motor is at an RPM of 180. Speed. All right, and then we want to know what is Y traveling at. All right, so remember what we know is that the gear ratio is equal to right, the input speed over the output speed, right? And what else is the gear ratio equal to? It's equal to N out over N in, right? So Z is N, yeah? If you remember, so that's going to be NY over NZ is going to be equal to WZ over WY. Oops. Right, and so when we do that, we end up getting what? Let's see, Z 20 over 60 is equal to 180 RPM over that. So let's see. Those cancel. That becomes 3 over 1. So the speed of, oops, I've gone off the screen there, sorry. So the speed of gear Y is going to be 60 RPM. All right, so this one's going to be 60 RPM. All right, and now we want to know what are the RPM of X. Okay, so if Y is turning at 60 RPM, we also know then that the speed of W is also going to be 60 RPM because they're on the same shaft. Alright, so now the gear ratio between those two, right, so for problem 3, we want to do N out over N in is equal to WN over W out. Okay, so N out is 30. And N is 15. The speed of W, which will be WN, is 60 RPM. And we don't know the speed of X. Alright, so that reduces to the number 2. So we have 2 times Wx is equal to 60 RPM. And Wx is going to be equal to 60 over 2. And that's going to be, the speed of that's going to be 30 RPM. Alright? So that's the answer to that. Alright, now we have a. Alright, so in number 4, I want to know these torques. I want to know the initial torque, and then number 5, I want to know the overall gear ratio. But to do this, I really need to know the overall gear ratio. So let's think about how our gear train worked again. We'll look back to the little sketch I made to work the problem. So we got Z is in, okay, and this is out, and then W is in, and this is out. So our gear ratio is going to be equal to, we got NZ over NY times NW over NX. Alright, so that's going to work out to be, if I look back to the numbers from my problem, 60 over 20 times W was 15 and X was 30. Okay, so this works out to be, oh, I can just do it this way. This works out to be 2, that works out to be 3, so this is going to be 6. Alright? So the overall gear ratio is 6. So we also know that the gear ratio is equal to the torque out over the torque in. So 6 is going to be equal to, the output torque is Tx, the input torque is Tz, so 6 is going to be equal to 1.5 foot-pound times divided by Tz. So when I rearrange that, I get Tz is times 6 is equal to 1.5 foot-pound. So Tz works out to be 1.5 divided by 6 foot-pound. And the torque at Z, when I punch that in my calculator, it's going to be 0.25 foot-pound. Oops, sorry, I went off the screen again. Okay? So that gives us the overall gear ratio was 6. That's the answer to number 5. And the torque at Z is 0.25 foot-pounds. Hope that helps.